Problem 942, DI string match. To solve this problem, we need to know one concept, and that's greedy. Greedy is all about basically knowing how to think optimally, and you develop this by doing lots of problems. So let's see how this applies to this question. We're basically given a string, and the letters of the string contain only I and D. I and D describe the relationship between numbers within the permutation. I means that the previous number is less than the current number, and D is the exact opposite. So if A and B were placed chronologically, then this I and D will describe, such a relationship between A and B. So how do we reconstruct it given ID? Well, for every I, it means the first value is a min relative to the subsequent value, B, which is a max, and the vice versa goes for D. So if we rewrite the whole output given ID in terms of mins and maxes, we get min, max, min, and then min, max. So this becomes min max, this becomes max min, min max, and then max min. Okay, so that's what it looks like. So basically, this is a min relative to this. Max is a relative to this min. So how do we basically reconstruct it? Well, the easiest way is to keep a min n and max n for what each of these should be given where we are in the array. And they always get initialized to be the smallest and greatest values permissible in the range respectively. This way, we're always going to maintain a relative pair in terms of relative mins and maxes. So for every time we assign a min, we increment n by 1. And for every time we assign a max, we decrement it by 1. So it gets 0 and n, that's a min-max pair. We get 1 and n minus 1, that's a min-max pair. 2 and n minus 2, etc., etc. So basically, if we apply this in practice, this will become 0, this will become n. And now, min n is 1, and max n is n minus 1. And now we need a min. The current min we can use is 1. So 1 goes right here. Then min becomes 2. But max doesn't get incremented yet because we never used it. Now we used it. So now max n becomes n minus 2, and min gets used. In our case, it's currently 2, so 2. In our case, n is equal to 4. So therefore, this is 4, and this is 3. And that's the whole logic. And with that, we can program this up in Python, and we're good. So we're going to need an array that stores all of the numbers. Min n will represent the min, max n will represent the current max we can use, which is the length of the string. So now we can iterate through every letter. So for letter in S, if this letter is equal to I, then we have to append the min value to R, and we decrement min by 1. Otherwise, we append the max value, and the max n gets, this would be increment, because we go up. Min goes down, so decrements by 1. But this is not good, right? Because we have one more number than we do have letters. So let's change this. So for letter in range of 0 to s minus 1, we're going to do s of letter like that. And here, once we're done, we purposely save the very last element, s of length s minus 1, for last. The very last character, if it's D, is going to represent a max, then min. And if it's an I, then it's going to represent a min, then a max. So we basically have the exact same if statement. We just have to do it outside so we can get 2 in 2 characters appended. And in our case, if this s of length s minus 1 is equal to I, then we just append min n. I is less than, we append min n, then we append max n. Otherwise, it's the exact opposite. We append max first, we append max first, then min. So we just change it up like this, and we're good. We return R at the very end, and that should work. So let's run it. And it doesn't work. So why is that the case? Because s is a string. So we're going to let n be the length of s, so n minus 1. And there we go, so let's submit. And that's the solution.